Alright folks, so this video is going to focus on the perpendicular bisector. There's two things we need, just like with altitude and median, in order to write my equation in point-slope form, which is y minus y1 equals m times x minus x1. Those two things are a point and a slope. So, the point, when I'm dealing with a perpendicular bisector, or when I'm asked to write an equation of a perpendicular bisector, the point is always going to be the midpoint of the segment that is asked about in the question. So they'll say, for example, find the equation of the perpendicular bisector of segment AB. Well, you need to find the midpoint of segment AB. In addition, I need a slope. All I'm going to have is one point. That's the midpoint. So in order to find the slope, I need to use the fact that I'm dealing with something that is perpendicular. So if they want the perpendicular bisector of segment AB, I'm going to find the slope of segment AB and take its opposite reciprocal. That's my perpendicular slope of the segment being bisected. So I find the slope of the segment being bisected and take its opposite reciprocal. Let's take a look at one example of this. So I skim through these other examples, and here we have our same ordered pairs, and again I'm going to sketch them quickly. A is at 2, negative 2, B is at negative 8, 12, we'll call that right here, and C is at negative 1, 3, so it's not exact at all, but we'll call it right here, negative 1, 3. Again, I'm not at all concerned about the triangle in particular. I will draw it in because that is what we're dealing with, but what I'm concerned is, in this case, the perpendicular bisector of segment AB. That means segment AB is my major focus here. I'll solidify that line because that's the only line that really matters, the only side of my triangle that really matters here. I could in fact erase point C completely when I'm dealing with a perpendicular bisector. Step 1 is I need a midpoint of a side. What side? Well, it has to be the side that I'm dealing with. I'm dealing with segment AB. I need the midpoint of segment AB. Okay. So I know that B is at negative 8, 12, A is at 2, negative 2. The midpoint, right here, which I will call M, cuts that in half. So I know that M is going to be negative 8, my x-coordinate, plus 2, my other x-coordinate, over 2, followed by 12, my y-coordinate, plus negative 2, my other y-coordinate, over 2. So my midpoint, negative 8 plus 2 is negative 6, divided by 2 is negative 3. 12 plus negative 2 is 10, divided by 2 is 5. That's the midpoint that I have to use. That's the point that I use to write my equation. So, slope is the next thing I need. I'm writing the equation of this line. It is perpendicular and it bisects segment AB. The only point I know on that line is point M. I can't find slope using one point. So, I am resorting to finding the slope of segment AB. So I know that point B is negative 8, 12. I know point A is 2, negative 2. To find my slope, negative 2 minus 12, bottom minus top, that's negative 14. 2 minus negative 8, bottom minus top, that's 10. That gives me a slope of negative 14 over 10 I always simplify my fractions. That simplifies to negative 7 over 5. That's the slope of segment AB. I'll put that in here, negative 7 over 5. My slope is of segment AB because that's what I'm dealing with. That's not the slope I use in my equation, though, because this line is not the same as this. In fact, since they're perpendicular, it's the exact opposite. This has a negative, this does not. This is 7 over 5. This is the reciprocal 5 over 7. I now have my point and my slope that I will use in my equation. Y minus your y coordinate equals your slope, 5 over 7, times x minus your x coordinate, but it's minus negative 3, becomes plus 3. There's the equation of my perpendicular bisector of segment AB.